Hello everybody, welcome to the first episode of my series on computer-guided drones. In this first episode, we'll be looking at a number of ways that we can have a computer directly control a drone. This is a crucial first step in allowing a computer to directly control your drone. The methods shown in this first episode could be applied to a variety of RC vehicles, which could be a drone, an RC aircraft, an RC helicopter, an RC boat, or RC car. The three ways of allowing your computer to directly control your controllers is first, through a servo motor external control, two, a relay/MOSFET internal control, and third is a voltage injection internal control. The first method, which is the servo motor external control, is nice because it's not invasive. You're just directly attaching the servo motors to the controller and allowing the servo motor to control your controllers directly from the outside without having to break into the controller. The pathway to method 1 starts from the computer sending a signal through the microcontroller to the servo motor, which then translates the mechanical motion on the controller, which then sends its control signals via RC to the drone. In this video, you can see that the setup is that the RC aircraft is being controlled by a servo motor external control. The servo motor is glued on to the controller itself for stability reasons, and the servo motor are controlled by the microcontroller, which is then connected to the computer via a USB cable. The USB cable is how the computer sends its movement instructions to the RC aircraft, therefore controlling it directly. Now we moved on to method 2, which is a MOSFET/relay internal control. This method is called the internal control because you actually have to physically open up your controller and hook it up correctly to make this work. Method 2, like method 3, depends on the joypad, which is inside a potentiometer, and which, as a potentiometer, operates as a voltage divider. Therefore, if you understand how a voltage divider works, you will know how to have the MOSFET or relay connect in such a way that it will control the controllers directly. So how the MOSFET and the relay works when they're connected properly to the potentiometer is that when they're shorted on the top half of the voltage divider, then the bottom half will have a full voltage drop. And when you short the bottom half of the potentiometer with a MOSFET or a relay, that will produce a voltage drop of 0. When the joypad is on its topmost position, for example, then the voltage drop across the potentiometer will be 0, let's say. And then when you push it all the way down to its extreme downwards position, the voltage drop across the potentiometer will be at its maximum, which is 3.3 volts. So the MOSFET or the relay either allows the voltage drop to be 3.3 or 0, which is essentially extreme up or extreme down position. By changing the duty cycle of the signal that is going into your MOSFET or your relay is a way of controlling the amount of motion that your drone will perform. Let's say you want to control your drone to go to the right. So at 100% duty cycle, it will cause the drone to go to the right at the fastest speed available. But if your duty cycle is, let's say, 10%, that will cause the drone to go to the right very slowly. This method is known as pulse width modulation. In this video, you can see that I took apart a controller by removing its covers and taking out the PCB from the backplate. All 3 screws will be taken out flip it to the back and you'll see 3 points for each potentiometer. There's 2 potentiometer that is connected to every joypad, and the wires will be sticking out as such. By shorting these different wires, you can, like I said from a previous slide, that you can control the amount of voltage drop. So here in front of us we have a joypad, which underneath, inside, is a potentiometer. You can see that there's 2 potentiometers in green, one for each of the axes. There are 3 associated pins corresponding to the voltage divider circuit. Now we move on to the final method, which is voltage injection internal control. In this method, which is invasive as well, like method 2, involves the removal of the potentiometer with a desoldering tool. Like I said previously, a potentiometer is a variable voltage divider. At its maximum, the potentiometer will produce a voltage drop of either 0 volts or 3.3 volts. 1.64 volts will be in its neutral position. Knowing this, and with the potentiometer removed, we could just directly connect the microcontroller output to the 2 points inside the potentiometer, where the voltage drop is measured. By doing this, you can directly inject the voltage into the controller. For example, if you wanted to go to the extreme right, you would input you'll have the microcontroller produce a voltage of, let's say, 3.3 volts. And if you want it to be neutral, then you will have the microcontroller produce a voltage of 1.64 volts. And then if you want it to go to the extreme left, you would have the microcontroller produce a voltage of 0 volts. This is how voltage injection works. And it is called voltage injection because you are directly putting in the voltage by removing the connections to the potentiometer. In this setup here, we have the voltage injection method. Connected to where the joypad used to be on the potentiometer connections is where the microcontroller is connected to it. In between the microcontroller and the joypad itself is a PWM to analog converter, because the joypad will not read PWM signals, but it will only read analog voltages. This is the end of this episode. In the next episode, we will make a little short demonstration video of a computer that is directly controlling a drone. Thank you everybody for watching, and stay tuned for the next episode.